Alright, I'm going to start 6.1 with solving inequalities by addition or subtraction. First thing I need you to know is to familiarize yourself with this notation, set builder notation, just a way for us to represent our solution set. Remember, this is an inequality. We don't just have one answer. We have multiple answers, more than one answer. So therefore, we need to have a clear way to express our answers, and this is how we represent a solution set. Okay, it has the braces outside, and of course this symbol right here, this bar, is to represent the word such that. So when you say it, it means there exists a variable x such that x is greater than 3. So that means your solution is going to be anything that is bigger than 3. Okay, so that's what we call a set builder notation, and this is what it looks like, and I want you to be able to use this every single time when you try to express your solution set. Okay, let's take a look at this first example, which is very straightforward. We have I'm trying to make sure that you understand that, either way, it looks like we're solving for an equation. Okay, let's set up an equation first. D plus 5 equal to 7. And if you recall how we do it, we solve for the variable d. We have to get rid of 5, so therefore we perform the opposite operations. We subtract 5 both sides. We're going to have d equals to 2. That's easy, right? That's one specific solution. Now, this time we don't have that. We have an inequality. So same exact kind of problem, but this time instead of having equal signs, I have this symbol. And this symbol is what? Don't forget, if you don't remember, refer back to the previous lesson about this chart right here. It has 4 specific symbols that you need to remember and the keywords for each one. Okay, so please definitely try to spend some time reviewing these words, these terms, so that you are better with recognizing them next time. So in this case, it's d plus 5 less than or equal to 7. And we solve it the same way we did it before. We subtract 5 both sides. So we end up with d still less than or equal to 2. Okay, we got that. That's very simple, very easy. Now, how do we express this as a solution set? Don't forget it. We open the braces. We know we're using the letter d, so here's d. There exists a letter d, variable d, such that d is less than or equal to 2. So it's pretty much the same. You just that you have to insert the braces, the bar, and the letter in the front. That's it. Okay, so how do you graph this? Here's your number line. Here's the 0. Okay, this positive 2 is going to be on the right hand side. Locate 2. This time, this symbol, so we know we have to use an inclusion, right? We have to use a solid circle. Anything that's less than. Remember, I said less than specifically is going to be on the left hand side. So therefore the arrow is going to be on the left hand side. Let's check it to make sure that our solution is correct. We found that anything that's less than 2 is going to be a solution, right? So let's check and then randomly select one number that's less than 2. So let's try 0. So let's check 0. 0, I'm going to plug into this inequality into d. So it's going to be 0 plus 5 less than or equal to 7. Subtract a 5 over. Then, of course, well, we don't need to do it. Sorry. All I have to do is 0 plus 5 is 5. Is 5 less than or equal to 7? Yes, check. So you know that you're on the right track. Okay, so go ahead and try this one yourself. Remember, this comes from your actual in-class work for the next day, so I encourage you to go ahead and get this done before you come back, because I will be checking in on you on that. So there it is. Okay, so try that problem out yourself. I want a solution set expressed using the set builder notation, and I want you to go ahead and check to make sure that your solution is correct as well. Okay, let's check this problem out. So this time pretend I have negative 7 greater than 20 plus c. So let's try to solve it the same way. We know we have to solve for the variable c, so we have to isolate c by subtracting 20 both sides. So c now is on the right hand side, and negative 7 minus 20 is going to be negative 27. I want you to express this as a solution set, so here we go. We open the braces, and here's the c, such that c, now read this. Notice that the mouth is facing a negative 27. So that means this is actually bigger than C, right? So when you start by using the variable first, C is actually less than, right? Negative 27. So I'm not really switching the symbol at all. I'm just making sure that the variable C comes first. C still is less than negative 27. So when you try to graph that in a number line, here's my 0. I'm just going to go and try to locate negative 27, which is on the left-hand side. And we know C is less than that, so therefore less is to go to the left-hand side. And since the symbol tells us that we don't include, right? Don't include means we have to use the open circle, and it's going to be pointing to the left-hand side. That's how we got our answers. Remember, this time we want to check to make sure that our answer is valid. So let's try to pick a random one that's on the left-hand side, negative 27. Let's say negative 30. I'm going to take that and plug it into C, negative 30. There you go. And let's see if our answer is correct. 20 plus negative 30 is going to get us negative 8. And as you can, I'm sorry, not negative 8, negative 10. And as you can see, negative 7 is indeed greater than negative 10. Checked. We got our solution correct. And of course, I want you to go and try this problem out. 8 less than or equal to r minus 14. Work that problem out, and we'll check that answer when you come back. Okay, here's the last example I wanted to show you. Here's negative 9 plus 2a less than 3a. So since we have variables on both sides, the rules tells us that we want to have variables on one side, right? So let's move all the a's to one side, move it by, of course, forming the opposite operation, minus 2a both sides. So we end up with negative 9 less than a, okay? Now, let's write that as a solution set. Here's a brace. It's letter A, such that the variable a is, once again, the mouth is facing the letter A this time. I mean, this is greater, right? This is a bigger value, so a is greater than negative 9, okay? Make sure you read it carefully. Notice the mouth is facing A. The mouth here is still facing A. I'm not changing anything. I'm just making sure that the variable comes first. So a is greater than negative 9. So when we plot that on our number line, here's a 0. So here's negative 9, which is some distance apart from 0 on the left-hand side. And once again, since we don't have, this is exclusion, we don't have the bar below, we're going to be using an open circle. Anything that's greater than 9, as you know, greater, it's going to be on the right-hand side of it. Okay, so there we have it. We have our solution set. Let's test it, pick a 0. Let's say anything on the right-hand side. So I'm going to use a 0 here to test. Plug it right back into A. And let's see if it's true. Negative 9, 0. Is 0 greater than negative 9? Yes. So therefore, our answer is valid. Okay. I want you to go ahead and try this problem out yourself. And hopefully you get your answers correct as well. Okay. I'll see you tomorrow.